Welcome to the Deep Dive. This is the show where we take your stack of sources, pull out those crucial nuggets of insight, and really try to deliver a complete understanding of some pretty complex topics. And we do it fast. Today, we are getting into one of the biggest architectural pivots happening in AI right now. I'm talking about the launch of NVIDIA Nemotron 3. Our mission here is to dissect this new open model stack to really understand the huge efficiency claims they're making and figure out what this all means for anyone moving from, a simple chatbot to these complex multi-agent AI systems. We're going straight to the sources you shared.
Okay, so let's unpack this shift first, because I think the context is it's everything. For a while now, the big win for companies was getting one simple assistant up and running, a chatbot, right, to handle single queries. But that's changing so fast. We're now moving into what people are calling collaborative agent workflows.
Which is a whole different ballgame. Totally. These are systems where you have multiple specialized models, all coordinating to execute these really complex multi-step jobs. So think of it less like talking to a digital assistant and more like, I don't know, managing a task force of digital employees.
That's a perfect analogy, actually. And that move, the one to managing a task force, it immediately exposes these huge enterprise-level production pain points. And that's exactly what Nemotron 3 is built to solve. When you've got 5, maybe 10 agents all talking to each other, solving a problem over dozens of steps, you suddenly hit massive communication overhead. You hit soaring inference costs because you're running all these processes at once. And, maybe most critically, you hit something called context drift.
Okay, context drift. Let's define that. For anyone listening who's mainly dealt with, single-turn interactions, what is that pain point?
Sure. So context drift is where the system, over a really long, complex process, let's say a 50-step financial analysis or debugging a huge code base, it just loses sight of the initial instruction.
It forgets why it started.
It forgets the mission, or key pieces of data from way back at the beginning of the chain. And this means the AI starts to hallucinate, or the final output is just totally irrelevant because an agent forgot the core objective. The longer the workflow, the higher that context risk becomes, and the harder it is to even validate what the system is doing.
So Nemotron 3 isn't just another model that's a little bigger or a little faster. It's really being positioned as the core technology to make these big, sprawling, agentic workflows reliable and, I guess, cost-effective enough to actually run in production.
That's the key. And what's really fascinating is how NVIDIA is tying this idea of efficiency back to trust and transparency. Jensen Huang was quoted saying that open innovation is, the key foundation for AI progress. Nemotron 3 is an open platform, the tooling is inspectable, and this all feeds directly into this idea of sovereign AI.
So sovereign AI. So that's the ability for an organization to keep total control over their own data, their own models, even when they're using this powerful foundational tech.
Precisely. If you are a huge bank, or a government agency, or any heavily regulated enterprise, you have very specific data governance mandates. You need models that align with your internal security protocols, your values, and so you often prefer open weights because you can actually inspect the tooling, understand its alignment, and deploy it where security and control are just non-negotiable.
I see. So the distinction is Nemotron 3 is for those high-volume critical tasks, but it keeps the hood open for places where that data control is paramount.
Yeah.
So what's the trade-off? Are you sacrificing some of that bleeding-edge performance you'd get from a closed-source model, or is Nemotron claiming you can have both?
Well, that's the core competitive bet, right? The sources suggest that by leveraging this incredible architectural efficiency, which I know we're about to get into, they're aiming for performance parity, or maybe even superiority on specific metrics like throughput without sacrificing the control you get from open weights. They're solving the scaling problem not with brute force, but with surgical efficiency.
Okay, that makes the architecture the real story here. So let's get into the engine room. Because the central innovation it's pretty technical, but it's critical for you to understand.
Yeah.
The hybrid latent mixture of experts, the MOE design.
Right. And for listeners who have maybe only heard that term OE, it sounds really complicated, but the idea behind it is actually pretty elegant, and it's the key to why this thing is scalable. In a traditional large language model, when it processes just one piece of input, a single token, It activates all of its parameters. That could be hundreds of billions of them for every single step.
That sounds incredibly inefficient. It's like requiring your entire 500-piece orchestra to play every single note, no matter how simple the melody is.
Exactly, it's total overkill. But with a MOE design, the model is built with many different specialized subnetworks. These are the experts. And when it processes a token, it uses a router to decide which few experts are the most relevant, and it only activates that small subset of parameters.
So it's like a giant specialized library. But instead of forcing the AI to read every single book for every query, it knows exactly which 2 or 3 shelves to check.
You got it. The massive memory and knowledge are still there, which keeps the quality high, but the cost calculation completely changes. You're only tapping into a fraction of it for the actual work, for the inference step. This design is what lets Nemotron 3 keep that quality high while just slashing the compute required per token.
And that matters so much for these agent systems because, like we said, the bottleneck isn't one model's size. It's the total throughput and the operational cost when you have hundreds of these agents running at the same time, all interacting. The MOE design is the efficiency valve that lets these systems scale without the cloud bill just exploding.
Yeah, it's the difference between a cool research project and a viable commercial service.
It really is. Okay, so this design sounds great in theory, but the tangible results, the raw numbers on speed and cost, that's where the rubber meets the road. Let's look at the 3 tiers they actually built around this architecture.
So they've got these 3 tiers, which basically give developers options all along that cost versus accuracy curve. It lets them pick the right digital teammate for the job. The entry point is Nemotron 3 Nano. This is your lightweight workhorse. It's perfect for those highly efficient targeted tasks. It has 30 billion total parameters, but, and this is the key, it only activates up to 3 billion at any one time. This version is available right now.
Okay, then you step up to the middle ground, Nemotron 3 Super.
Right. Super is much larger. It's around 100 billion parameters, and it activates up to 10 billion per token. This one is aimed squarely at multi-agent reasoning with a focus on low latency, so the speed of the response. This one and the Ultra model are slated for the first half of 2026.
And that brings us to the heavy hitter, Nemotron 3 Ultra.
Yep, Ultra. It clocks in at around 500 billion parameters, and it can activate up to 50 billion per token. This is your deepest reasoning engine. It's the core brain you'd need for those really complex, long-horizon workflows we were talking about.
What immediately jumps out for the sources are these crazy efficiency claims that are tied directly to this MOE architecture. I mean, these are the metrics that production teams really care about when they're facing massive scale. We're talking up to 4x higher token throughput compared to the last generation Nemotron 2 Nano.
Which is huge.
It's huge. And critically, up to a 60% reduction in what they call reasoning token generation. A 60% reduction in your core computational unit. I mean, that directly translates to a massive drop in inference costs that can change the economics of an entire product line.
And if that's the speed and cost part of the equation, what about the quality? That brings us to their really incredible claim on context memory. Even for the smallest model, Nemotron Nano has a massive 1 million token context window.
1 million tokens.
Yeah.
On the smallest model. That's huge. How does that actually feel different for a developer compared to the context limits they're used to right now?
Well, it directly attacks that context drift problem we talked about earlier. If you're processing, say, a multi-volume legal filing or a year's worth of security logs, 1 million tokens lets the agent hold all of that in its head, you know?
Right.
It maintains awareness from start to finish. It just drastically cuts the risk of the system forgetting the core data or the initial mission parameters during a job that might take hours.
That is a true game changer for reliability inside these systems.
Absolutely. And there's a quick but important technical detail on the bigger models, Super and Ultra. They're using something called NVFP4 4-bit training on NVIDIA's Blackwell architecture.
Okay, so that's not just some engineering footnote. Why should an enterprise user care about a technical detail like NVFP4?
Because if you, as an organization, need to take a massive model like Nemotron 3 Ultra and fine-tune it with your own private data, your security manuals, your financial docs cutting the memory needs with this technique speeds up your development cycle from weeks to just days. It makes customizing these huge models much more accessible and agile.
So you've got this architectural efficiency from MOE, and you combine it with training efficiency from NVFP4. But look, Building good agents requires more than just efficient model weights. The sources make it really clear that Nemotron 3 is being released as a full stack.
Exactly. This full stack approach is so critical for anyone building real production agents. So beyond just the open model weights, they're releasing a massive 3 trillion token dataset for pre-training and reinforcement learning. And they've included a really specialized asset, the Nemotron agentic safety dataset.
A specialized safety dataset.
Yeah.
Why is that necessary for these agentic systems specifically?
Because the risk profile just goes up exponentially when you have 5 specialized AIs talking to each other instead of one bot talking to one human. The agents could, in theory, conspire or circumvent safety rails or even create new attack paths without any human oversight. So this agentic safety dataset gives you a framework for evaluating those unique security risks that only appear in these complex coordinating systems.
And to manage all that coordination, they've also released a bunch of open source libraries.
That's right. They're basically providing the whole toolkit. You've got Nemo Gym, which is the environment for training. You've got Nemo RL, which lets you train the agents to behave correctly and follow rules. And maybe most importantly, you have Nemo Evaluator. This is crucial because testing 5 agents is way more complex than testing 1. You need specialized tools to make sure they don't hallucinate or violate policy when they talk to each other. It's the validation backbone for enterprise trust.
And it seems like this is already translating into some massive adoption signals. The proof is there that this stack is a direct accelerator for enterprise strategy. I mean, look at ServiceNow. It's their CEO, Bill McDermott. He framed this integration with Nemotron 3 as basically the ideal architecture for intelligent workflow automation. For a company like that, handling just massive volumes of enterprise tickets and operational data, that 4x throughput and 60% cost reduction, that's not academic.
No, it's fundamental.
It's what's necessary to automate their entire workflow at scale, efficiently and accurately.
And then you've got this fascinating use case from Perplexity, which really highlights this idea of an agent router. Their CEO, Aravind Srinivas, mentioned that they use their internal router to send workloads to the best possible model for the job.
So they can send cost-sensitive or specific types of tasks over to Nemotron 3 Ultra when it's the best fit.
Exactly. But they can still leverage other, maybe proprietary models when those unique capabilities are needed for a different query.
I think that really illustrates a key trend for you, the listener. The future AI system isn't going to be some monolithic service you subscribe to. It's a flexible network. You'll use the cost-effective specialized open model when it's the fastest and cheapest option, and you'll route elsewhere when you need to.
And this hybrid approach and the openness of Nemotron 3 is also making it really appealing to early-stage companies. The sources quote Mayfield's managing partner, Navin Chadha, who points out that Nemotron 3 gives founders a super cost-effective running start on building their own specialized AI teammates. By using the whole NVIDIA Inception ecosystem, startups get a much faster, cheaper path from just a prototype to a real production system.
And finally, let's talk about availability. Nemotron 3 Nano is already out there. It's live right now, which means you can start experimenting and building today. You can find it on platforms like Hugging Face and other inference providers.
And crucially, it's also available as an NVIDIA NIM microservice. Now, why is that so important for the enterprise? It means the model is already packaged, it's optimized, and it's ready for immediate scalable deployment on NVIDIA hardware. It just minimizes all that friction for big organizations that already run on that stack. And they're also pushing Nano out to AWS through Amazon Bedrock, which makes deployment almost seamless for a huge number of cloud users.
So let's just synthesize what we've covered in this deep dive.
Yeah.
Nemotron 3 really represents this clear, focused push to solve the main scaling challenges for the next generation of AI apps.
Yeah, it's a significant move. It's about making powerful, specialized AI, which is the absolute core of any effective agentic system, cheaper, faster, and more transparent. The key enablers are that commitment to open models for control and that hyper-efficient hybrid latent MOE architecture to manage the cost.
And this shift is going to fundamentally impact how complex multi-step tasks get automated across the board. It doesn't matter if you're building software or doing financial analysis or managing security operations. We are moving well past the simple single-task bot and into, well, genuinely complex collaborative digital intelligence.
And that leads us to our final question for you to think about. The sources we looked at, they show a future where AI systems are made up of these small, efficient, specialized experts that all talk to a central router, like what Perplexity is doing. So, if efficiency and specialization are the new bottlenecks, how does this drive a shift in your organization? A shift away from just buying one big, monolithic, one-size-fits-all AI system and towards building or maybe even hiring highly customized, task-specific AI teammates inside your own enterprise.
And that's a wrap on this deep dive. Thank you for tuning in.